October 1942, the North Atlantic. Wind force 6, visibility 1 mile. Grey waves rise and break against the steel bow of HMS Pretoria Castle, a converted escort carrier operating south of Iceland. Every surface shudders under the combined weight of wind and machinery. Salt spray crusts the deck rails. Beneath the flight deck, inside a dim operations room lined with charts and signal cables, an unfamiliar device hums quietly in a corner. It is little larger than a suitcase, fitted with twin aerial masts and a rotating switchboard marked Type 271B. Its beam sweeps invisibly across the sea, painting echoes on a green cathode screen. At the table stands Lieutenant Commander R.M. Fenton of the Royal Navy's Anti-Submarine Experimental Group. He records each pulse in a worn ledger, noting signal strength, bearing, and range. His operators have been told little. They know only that this unit is not standard radar. It is a decoy transmitter, an imitation that mimics the pattern of a convoy radar set, designed to appear genuine to enemy receivers. To German U-boat crews using radar detectors, the signal seems like a target. The real ships, far to the south, remain invisible. The crew around Fenton work in short, economical movements. One adjusts the azimuth dial, another recalibrates the transmitter frequency. The room smells of heated dust and oil. A clock ticks above the plotting table, its rhythm barely audible beneath the thrum of the ship's turbines. Every 15 seconds, a pencil line is drawn across the chart, marking the sweep. There are no voices raised, no wasted motion. Only the low murmur of filtered air and the steady oscillation of electronics. Above deck, the Atlantic air is raw and metallic. At dusk, signalmen raise the blackout screens and switch the transmitter to continuous mode. To the untrained ear, nothing changes. But on the cathode display, faint arcs begin to appear, distorted returns that drift and then fade. Fenton notes them, cross-references their bearings, and orders the operator to maintain transmission. 20 miles to the north, a U-boat captain aboard U-boat 597 detects what he believes is the radar signature of an unescorted merchant group. He alters course by 9 degrees and submerges to periscope depth. Through that night, the decoy continues its silent broadcast. The Royal Navy's escort group maintains a slow, deliberate pattern, circling a fixed coordinate as if guarding invisible cargo. Each signal pulse is timed to reinforce the illusion. Hours later, hydrophone operators aboard HMS Mon detect propeller noise approaching from the north. The sound increases, then stabilizes. A faint bearing is plotted, and Destroyer Mon turns into the wind, readying depth charges. The U-boat, guided by its own false intelligence, closes within 5 miles. At 2:47 hours, the first explosion breaks the surface tension of the sea. The concussion lights the night with a brief orange bloom. Water rises in a column and falls again in sheets. When it clears, only fragments of wood and an oil slick remain. The operation log records a single line, probable contact, enemy submarine destroyed. Fenton writes it without comment, then marks the position on the chart with a red pencil. From the open bridge, the horizon is a uniform grey. The radar antenna continues its rotation, unchanged. To the west, dawn begins to thin the mist. In that moment, no one aboard considers the implications of what has occurred. The decoy device, dismissed months earlier as tactical nonsense by senior officers, has drawn a submarine into range and ended its patrol. It will be another 6 months before official reports describe the technique formally, a deliberate imitation of radar emissions to lure enemy submarines toward false convoys. For now, the ship continues eastward in silence. Salt gathers on the railings. The green trace on the radar screen fades to nothing. The Atlantic absorbs the evidence, leaving behind only coordinates and a single coded entry in the Royal Navy's night log. By early 1943, the Admiralty ordered a series of controlled trials to test what Fenton's field notes called Project Swell. The name carried no hint of its purpose. In a secured hangar at the Royal Navy Signal School in Portsmouth, technicians disassembled the decoy set recovered from Pretoria Castle. Its aluminum casing was scarred by salt corrosion, its dials stiff from repeated exposure. Each component was catalogued and laid on a canvas mat, oscillator tubes, frequency coils, and the central pulse modulator. The atmosphere inside the hangar was silent except for the rhythmic hiss of soldering irons. Commander George Hunter, head of the Radar Development Section, supervised the reconstruction. He insisted that the equipment be operated exactly as it had been at sea, without laboratory shielding. The technicians complied, running copper lines along the walls and erecting a makeshift mast from 2 iron scaffolds. The goal was to reproduce the distortion patterns that German radar receivers might detect at periscope depth. Every test began the same way: a controlled pulse was transmitted, the signal captured on a receiving antenna submerged in a saltwater tank, and the waveform printed on photographic paper. The prints revealed something unexpected. Real radar from convoy escorts produced consistent peaks at 12-centimeter intervals. The decoy unit, by contrast, emitted broader, irregular pulses that shifted slightly with every rotation. To an Allied operator, this represented poor calibration. To a German detector, however, it suggested multiple sources, the signature of a convoy spread across miles of open water. Hunter underlined the finding in red pencil. If such false patterns could be projected in chosen sectors, submarines would waste hours pursuing ghosts. At the same time, captured intelligence supported the theory. From intercepted Enigma traffic, British analysts at Bletchley Park noted repeated U-boat complaints of phantom convoys north of the Azores. Patrol logs mentioned radar signals that seemed to multiply or drift unpredictably. One report by Captain Lieutenant Hans Gunther Brod described chasing a target for 6 hours before surfacing into an empty sea. His message ended with a single frustrated line: "Our detectors must be faulty." The analysts marked it with a green tag, possible correlation with Project Swell activity. Field deployment began quietly. Modified decoy transmitters, now built in small batches at the Admiralty Signal Establishment, were fitted to converted trawlers and corvettes. Their operators were drawn from radar ratings trained to follow scripted transmission routines. Every pulse had a duration, a delay, and a sweep angle predetermined to simulate real escort movement. Logs from these missions describe painstaking attention to detail. Bearings were shifted 5 degrees each hour. Signal intensity was reduced during daylight to mimic convoy radar discipline. From the perspective of the men aboard, the work was uneventful and strangely detached. They navigated empty sectors, transmitted at set intervals, and observed the sea through binoculars. The decoy ships rarely sighted the submarines they lured. Confirmation came later, through other channels: depth charge reports, intercepted German communications, or unexplained oil slicks in grid squares they had once occupied. The North Atlantic weather offered no leniency. In January 1943, HMS Abelia reported ice forming on antenna mounts and electrical arcing from the decoy transmitter's masthead. Yet the equipment endured. The key advantage of the system lay in its simplicity. It required no target, no return echo, only power and timing. While radar science was advancing toward centimeter precision, this invention relied on deception at its most basic, convincing the enemy that the sky itself was filled with signals. By March, the Admiralty's Anti-Submarine Warfare Division compiled comparative charts of U-boat losses. Sectors covered by decoy transmission showed higher encounter rates and shorter patrol durations. German commanders began reporting erratic radar interference across known convoy routes. They called it Funknebel, Radio fog. The word appeared frequently in decrypted messages, signifying confusion rather than clarity. On board Pretoria Castle, Fenton's team received copies of these reports with quiet satisfaction. No citation, no public acknowledgement, only a note in the margin, operational value confirmed. The decoy trick had left no trace beyond its own signal. It existed purely in the invisible space between machines, a false heartbeat that drew its hunters ever closer to danger. By May 1943, when the Battle of the Atlantic reached its turning point, British naval intelligence began to quantify what had once been anecdotal success. Analysts at the Admiralty's Operational Research Section compared patrol data from 42 decoy-equipped vessels against U-boat interception patterns recorded by Coastal Command. The results were not dramatic, but precise. In areas covered by radar deception broadcasts, submarine contact rates increased by 34%, while confirmed sinkings rose by 11% within the same grid zones. For a weapon that fired no projectile, such numbers were extraordinary. The statistical tables arrived daily at Derby House in Liverpool, headquarters of Western Approaches Command. Worn paper folders marked Swell results, confidential circulated among officers. Each line represented a calculated outcome: one ship transmitting, one submarine misled, one less convoy intercepted. The data did not glorify the system, it merely outlined cause and effect. The decoy radar trick, once dismissed as theoretical, had created a measurable distortion in the enemy's behavior. The reason lay not in the equipment's power but in the psychology of the hunt. German submarine crews depended on a device called the Metox receiver, later replaced by Naxos. Both detected Allied radar emissions at long range but offered no way to distinguish real convoys from false ones. When the sea filled with artificial pulses, confidence eroded. Captains who once trusted their instruments began surfacing less frequently, choosing deeper patrol routes, or avoiding the North Atlantic altogether. This behavioral shift, confirmed by decrypted Enigma logs, coincided with a steep drop in successful U-boat attacks, from over 90 in March 1943 to fewer than 30 by August. Royal Navy archives contain the original performance charts. One page shows parallel graphs, the number of active U-boats versus the density of decoy transmissions. As the latter rises, the former declines. No officer could attribute victory to a single cause. Escort carriers, lee lights, or improved depth charges all played roles, but the deception network quietly amplified them. By forcing submarines into disadvantageous positions, it gave air patrols time to detect and destroy. In an internal memorandum dated the 14th of June, 1943, Commander Hunter summarized the discovery in the terse language of engineering: enemy decision cycle disrupted by signal redundancy. Apparent convoy density increased beyond operational capacity. Recommend continuation. There was no mention of innovation or ingenuity. The report read like a maintenance note: detached, procedural, final. Yet behind it lay a transformation in naval warfare. The Allies had not simply improved their tools, they had inverted the enemy's perception of reality. Captured documents later confirmed the extent of that confusion. A U-boat flotilla diary recovered at Lorient contained marginal notes complaining of persistent radar ghosts and phantom convoys impossible to intercept. Engineers in Kiel tested their receivers repeatedly, convinced the fault was mechanical. One technician annotated his log: "If these signals are deliberate, the English have found a way to haunt the ether." The phrase circulated informally among crews: "Die Spuksignale," the ghost signals. From the British side, operational costs were minimal. Each decoy transmitter consumed less power than a galley stove and could be mounted on any small ship. Production records from the Admiralty Signal Establishment show 118 units constructed between February and October 1943, each tuned to emit in variable cycles to avoid pattern recognition. Maintenance crews logged fewer than 5 failures in active service. For every transmitter deployed, the estimated diversion of enemy submarines saved an average of 2 merchant vessels per month. There were no medals for the work. Most operators never saw a submarine, nor fired a weapon in anger. Their victories existed only in the coded silence between signals, records of ships that reached port unscathed, convoys that vanished from enemy charts, and oceans that seemed, for a few critical months, emptier than they truly were. In retrospect, the Royal Navy's experiment demonstrated a principle that would later define electronic warfare: success measured not by destruction, but by confusion. A transmitter, once called useless, had quietly rewritten the balance of power across the Atlantic. In the darkness between radar pulses, a new kind of weapon had been born, one built entirely of noise. After 1945, as the Atlantic convoys returned to peacetime trade, the files marked Project Swell were transferred to the Admiralty's post-war technical archives. Their covers carried no classification beyond obsolete equipment. By then, the decoy radar systems had already been dismantled or cannibalized for parts. The small ships that once carried them were repainted for coastal patrol or sold for scrap. No plaque or commendation marked their service. Yet within those boxes lay the earliest blueprint of deliberate electronic deception, the act of shaping the enemy's decisions without ever being seen. In 1946, a joint Royal Navy RAF analysis compiled under the title Radar Countermeasure Summary No. 12 drew a quiet conclusion: the introduction of radar simulation devices produced confusion out of proportion to their scale. The enemy's faith in his detection apparatus diminished. The document never reached the public, but its language foreshadowed the doctrine of post-war electronic countermeasures. The same principle would reappear in Cold War exercises, transmitting phantom aircraft on Soviet radar screens, creating entire ghost fleets on radio frequencies, and manipulating what the adversary believed existed. The surviving engineers who had worked on the early sets spoke rarely of their invention. Commander Hunter retired to civilian industry, consulting on radio navigation aids for coastal shipping. Fenton returned to field service before leaving the Navy in 1947. In interviews recorded 2 decades later, he referred to the work only as an experiment in invisibility. The phrase captured what numbers could not: the deliberate creation of nothingness as a weapon. German naval historians reviewing captured logs after the war recognized the deception's impact only in retrospect. Analysis of U-boat patrol records from late 1943 showed a consistent misallocation of resources, entire flotillas redeployed to sectors where no convoys had ever sailed. In effect, the British had forced the enemy to fight phantoms. Professor Herbert Mell, compiling data for the Federal Archives in 1959, described the outcome with precision: when the Atlantic was filled with false signals, the U-boats drowned in information. Technically, the invention's legacy persisted in unexpected forms. The post-war window chaff drops, the RAF's ghost echoes over radar nets, and the U.S. Navy's later Anolka hovering decoys all drew lineage from the same wartime logic: that deception, properly timed, is as decisive as firepower. In this chain of evolution, Project Swell stands as the unacknowledged prototype. In 1972, the Admiralty declassified much of its wartime radar correspondence. Among the papers released was Fenton's original 1942 report from Pretoria Castle. Its final sentence was unremarkable, written in steady ink across a fading page: enemy submarine approached signal source under false assumption of target, effect considered repeatable. Nothing more. No reflection, no analysis. Only confirmation that a trick once dismissed as impractical had worked exactly as designed. The document rests today in the Royal Navy Archives at Portsmouth, Catalogue reference RN AS 271B-42. The paper has yellowed, but the handwriting remains legible. It records the moment when deception ceased to be a side effect of war and became an engineered instrument, invisible, silent, and mathematically precise. No memorial honors the men who transmitted those signals. Their contribution lies buried in data and static, in the quiet lines of operational graphs and after-action summaries. The sea absorbed the evidence long ago. Yet the principle they proved endures in every modern defense system that blinds, jams, or confuses an opponent. The invisible war they began continues, fought not with shells or torpedoes, but with the calculated illusion of something that isn't there. The Atlantic wind still carries that faint echo. A signal that once drew hunters to their own destruction. And somewhere in the long ledger of naval warfare, a small entry remains: deception transmitter, effective. In the years following the war, naval engineers began formalizing what the decoy experiments had suggested, that information itself could be weaponized. The Admiralty's newly formed Signals and Radar Establishment at Malvern quietly inherited the technical records of Project Swell. Inside its red brick complex, researchers catalogued dozens of wartime devices, noting frequency ranges, pulse lengths, and field effects. Most were labeled obsolete or redundant, yet their designs formed the foundation for a new discipline. Where wartime radar sought to see, post-war radar science sought to mislead. Reports from 1948 show the transition in language. Terms like ghost signal were replaced by emission control, signature management, and countermeasure architecture. Engineers spoke less of tricks and more of systems, predictable, reproducible, measurable. The humble transmitter that once tricked a submarine was now treated as the prototype of an organized doctrine. The Navy called it electronic warfare, a phrase that would later define the Cold War without ever naming its origins. By 1952, NATO exercises in the North Sea incorporated radar deception units as standard equipment. British and American ships simulated phantom fleets to test response patterns, using updated versions of the 271B transmitter. The new models could project multiple false echoes across wide sectors, creating the illusion of convoys maneuvering independently. In these trials, submarines assigned to intercept the convoys failed to locate any real targets. Reports from the exercises read like echoes of Fenton's wartime logbooks: same confusion, same precision, now perfected. Meanwhile, intelligence historians revisiting the Battle of the Atlantic began to recognize that the Allies' victory had depended as much on perception as on production. The enemy had not simply been overpowered, it had been misinformed. Analysts in the Royal Navy Historical Branch compared submarine loss curves against documented decoy deployments and noted a statistical rhythm, a pattern of misdirection followed by concentrated U-boat attrition. The conclusion, buried in a footnote, stated, operational deception amplified material advantage. Across the Atlantic, American researchers at the U.S. Naval Research Laboratory reviewed captured German archives. Among them was a short technical memorandum from Kiel, dated September 1944, signed by Dr. Hans Rudenberg, chief engineer of the Kriegsmarine's radar division. It described an unexplained proliferation of simulated radar signatures of no apparent physical source. His last paragraph read, "If intentional, the method represents a new art of naval engagement, one that replaces force with perception." For decades, that single line would remain the most concise definition of what Project Swell had achieved. By the mid-1950s, the principle extended beyond radar. Radio operators began experimenting with frequency hopping, false communications, and controlled jamming to mask genuine transmissions. The idea was always the same: to crowd the enemy's instruments with believable lies. Even in aviation, where radar became the primary sensor, decoy tactics evolved into reflectors, flares, and stealth geometries, all descendants of a signal that once flickered across the Atlantic under a grey November sky. Back at Portsmouth, the original prototype transmitter was preserved, unofficially, by a junior curator who refused to scrap it. It rests today in the Royal Navy Museum's reserve collection, unlabeled, a box of rusting circuits on a wooden pallet. A small brass tag on the side reads simply, Type 271B Experimental, Obsolete. Its purpose is known to few visitors. Yet in the lineage of modern naval design, from electronic jamming pods to digital ghost ships projected on radar scopes, that small box is the ancestor of them all. Every subsequent generation of electronic defense, from the Malvern jammers of the 1960s to the satellite countermeasure suites of the 1990s, traces its heritage to this forgotten episode. Project Swell's men never saw the war, they changed, they heard it, measured it, and transmitted its illusion into the night. Their work demonstrated that deception, when precisely engineered, can outlast the conflict it was built for. The archives describe it without sentiment, first practical application of artificial signal deception at sea. Confirmed operational effect. That is the closing line of the final Admiralty report, dated the 7th of October, 1945. It carries no conclusion, no philosophy, only proof that invisibility, once achieved, does not need to announce itself. By the 1960s, the quiet experiments of the North Atlantic had become the backbone of a new strategic domain. The Royal Navy's Maritime Electronic Warfare School at Collingwood trained officers not to command guns or torpedoes, but to manipulate electromagnetic space. Their charts no longer plotted enemy convoys but radar lobes, jamming frequencies, and time delay patterns. What began as a wartime improvisation with vacuum tubes and hand-drawn charts evolved into an exact science, the controlled distortion of perception. Declassified NATO manuals from 1964 reference Swell-type signal simulation as a foundational case study. The text describes a transmitter projecting false echoes to induce incorrect tactical assessment. There is no mention of the men who built it, nor of the conditions that birthed it, only the method and its mathematical model. The formula is straightforward: credibility times repetition equals confusion. The principle that once lured submarines into the crosshairs now underpinned every electronic decoy in service, from radar reflectors to anti-missile countermeasures. During the Cold War, these ideas reached new sophistication. British Type 45 destroyers carried automated deception suites that could broadcast hundreds of synthetic targets simultaneously. Submarines deployed floating buoys emitting artificial sonar pings, creating the illusion of phantom fleets beneath the surface. American carrier groups used electronic repeaters to mask their radar cross-sections, making themselves appear smaller, slower, or farther away. Each of these systems descended from the same wartime insight, that confusion, engineered correctly, could equal survival. Intelligence archives later showed that Soviet analysts studying NATO radar patterns in the 1970s repeatedly noted signal redundancy inconsistent with observed fleet movement. They had no direct proof, only anomalies, waves of radar activity without corresponding ships. In effect, the Allies had replicated the ghosts of 1943 on a global scale. The technique's power lay not in what it revealed, but in what it concealed, the ability to make the sea lie. In academia, Project Swell remained obscure until the early 1990s, when researchers at King's College London published a paper on the origins of electronic countermeasures. They traced the lineage through scattered Admiralty files, correlating code numbers and test ranges. The study concluded that Swell represented the first systemic application of radar deception to influence enemy behavior, preceding all Cold War ECM doctrines. The paper attracted little attention outside military history circles, but within defense research it became a reference point, proof that electronic warfare had not been born from technology alone, but from necessity and imagination at sea. Today, digital descendants of those primitive transmitters operate invisibly across oceans. Their signals are no longer heard as hums or pulses but calculated noise within data streams, deceptive echoes inserted into enemy sensors by algorithm rather than operator. What began as a single false radar sweep now exists as software capable of simulating entire fleets. The essence, however, remains identical: to control what the adversary believes is real. In the Royal Navy Museum's archival wing, the preserved logbook from HMS Pretoria Castle sits open beneath glass. The ink has faded, but one line remains visible under light: 2:47 hours, probable contact, enemy submarine destroyed. No monument marks that moment. Yet from that quiet entry grew a new understanding of warfare, one where silence and illusion achieve what firepower cannot. The seas of the 21st century are crowded with electronics, sonar decoys, radar ghosts, cyber defense nodes pulsing beneath satellites. Each is a whisper from that first night in 1942, when a small transmitter turned the Atlantic into a stage of false signals and unseen traps. Project Swell proved that in war, the decisive weapon might not be what a ship carries, but what it convinces the enemy to see. The file remains in the archives, its label unchanged for 8 decades: radar decoy, Type 271B, operationally effective. Beyond the glass, the hum of modern computers fills the air, descendants of a single machine that once broadcast a lie so perfect it became a truth of its own.